Hi, welcome to this tutorial on PreciScan, one of the advanced features of the Opera Phenix. Before we get started, this tutorial is intended for advanced users of the Phenix. So if you are looking for an introduction on how to use it, go back, ask George, get training, come back to this when you're comfortable in all of the basic applications of the microscope. So what is PreciScan? It is a approach to automating pre-scan online analysis and high magnification rescan. It's particularly useful for imaging rare events, for example, dividing cells that are distributed unpredictably and unevenly across a well, because it allows you to perform a low magnification pre-scan. Then an analysis sequence runs to identify the regions containing those rare events, and those regions are marked and then re-imaged at a higher magnification. And all of this happens as one fully automated process, completely hands-off. So, what we need to do is set up the pre-scan experiment. So we start this video off by just showing where PreciScan is. You have your two scan modes. When you switch to PreciScan, you'll see that instead of one option to load an experiment, there's now two separate options, one for a pre-scan and one for a rescan. So you're going to set up the two halves of your PreciScan experiment as separate experiments and then run them together. I'm also just demonstrating here where the help section is. As with everything else, you right click and then select help, and you get a nice detailed breakdown of what each thing in the PreciScan setup panel does. But yeah, to begin with, we want to set up the low magnification pre-scan experiment. So we'll jump across to the setup tab. And then from here, we set up like any other experiment, making sure that we select the right plate type, obviously making sure that we select a low magnification objective that we want to run our pre-scan with. At this point, I move on to start setting up channels, and you will see in a second, I will skip forward, there we go, to after I've got some test images, because we're assuming advanced users here. We don't need to go through how to set up an experiment right from the beginning. What you do need to make sure you do is two main things. One is make a decision as to whether you want your pre-scan to be 3D using a Z stack or whether 2D will be sufficient. And obviously, if you're going to use a stack, keep the stack set up. If you're not going to use a stack, remove it and set the heights for each channel individually. And then you also need to optimize your imaging settings for each channel as you would for any other experiment, because we're heavily dependent on automated analysis working here to be able to identify our rare events. And that obviously is most effective when you check that your intensities for your target are over 1,000 above your background. Now, I've decided that for this example experiment, my target are going to be cells that are tagged with Alexa 647, which is why we're checking here that our 647 is sufficiently above background. And then once you've set that up, you just want to select all of the wells and fields of view that you want to image in your pre-scan experiment, and then you save your experiment with a name that you're going to remember, like pre-scan or anything else that's going to be memorable, so you make sure that you select the right experiment. Now, at this point, we don't need to select all of the wells that we're going to image. We just need to select one or two so that we have some representative images that we can then build our analysis sequence on. And that is our next slide. To build the online analysis sequence, you want to load the test measurement images and then build a sequence in the way that you're used to building, but making sure that the analysis that you're running identifies your target cells separately from the rest of your cells. So you'll see in this example, we calculate intensity properties for the 647 within each nucleus region, select population to select for the ones that have 647 above our desired threshold. And then crucially, we add a block called determine well layout, which is where we are able to have the analysis sequence tell the rescan sequence which fields to image. And there's a little tweak that we need to do to define results as well to make it work every time. So our next step is to build the online image analysis sequence. So we start off by coming into our Run Experiment tab and switching back from PreciScan to normal mode because we just need to run our pre-scan experiment here. And then we run the experiment. We give it a name, we hit start. I am hopefully here going to skip ahead to where the experiment is done. Wonderful. And then at this point, we have our test images. Obviously, have a quick look around through the wells, make sure that you have images that are kind of representative of your plate as a whole, images that actually have some cells in them. We haven't just imaged empty space, so that we have something consistent that we can build our analysis sequence on top of. And then we move on to the image analysis tab and begin to set up our analysis sequence. Now, obviously, this analysis sequence that I'm going to build here is completely specific to my rare event that I'm targeting, with that being cells that are positive for Alexa 647. Your analysis sequence, when you run PreciScan, is going to be entirely specific to you. Is going to be specific to identifying the rare event that you're attempting to image in your high magnification rescan. But here you can see, after a bit of skipping ahead, I now have, thanks to a select population block that's filtering for intensity of Alexa 647 in each cell, I've identified the rare events. The cells that I want to image are now highlighted in green. The cells that I don't want to image, that I'm not bothered about, highlighted in red. So now what we need to do is add a block that tells the rescan where to image. So we throw in our determine well layout block. You can see here it's selected the main nuclei population, but when we switch to nuclei selected, it's now only drawing these rescan fields of view around our cells of interest. And this is what we want to see. There's then a couple of other options that you can define in here. Again, the help guide is a great resource for if you right click on the orange bar at the top of the block, you go to the help guide, it'll tell you in detail what each option does. But you have basic things like well overlap, the rescan objective that you're going to be using, which obviously decides how big the field is. So make sure that matches whatever you set up in your rescan experiment. And then the last thing we need to do is come into the define layout block and make sure that for each of the options that you see, at least one result is included in the output, usually just number of objects, and also add in a formula result which calculates your rare event cells as a ratio to the number of cells in total. You don't necessarily need this result, but for some reason, the PreciScan seems to crash without it. Whereas every time I've run it with this formula result calculated, it's run smoothly without falling apart at any point. So I would recommend that you include it in. And then once you've got that experiment, that analysis set up, you want to save it, go back to your pre-scan experiment, and here we are adding it as an online job at the bottom of the sequence. Then once you've added the online job, make sure that you add in all of the fields that you wish to image in your pre-scan. And then at the point where you have the online job analysis included and all of your fields set up, you can go ahead and save your pre-scan experiment. And that is your pre-scan done and ready to be used in the PreciScan loop. With that done, we can move on to setting up the rescan experiment. This is going to be our higher magnification experiment that images those fields of view that we've marked as containing cells of interest, objects of interest, whatever our analysis sequence identified. The first thing you want to do is find a relevant region to set up your settings on. So what I'm doing here is looking at the test images and going, okay, there are here and here, we can see cells that are interesting to me. So let's choose our fields, as you can see over here, Let's choose fields of view with our higher magnification objective, where I think those cells are going to be more or less. Because obviously when you do your rescan, you're only going to be imaging areas that have those cells. So those areas are the areas that you want to set up and optimize your settings for. So that's the first thing we're going to do, is try and image some regions of interest. So you can see here, we've done a rescan, we've done a test image, and there on the bottom right of our image, we can see we have a cell of interest. So now I'm just doing my usual settings optimization. I'm checking intensities of channels. I'm making sure that differences between target and background are suitable for analysis. You can decide here, again, if you want a 3D stack or if 2D rescan is sufficient. So here you can see I'm removing the stack and defining a height for each channel because I've decided I don't need 3D rescan. You can also, because I've built this based off of the PreciScan experiment, the online job analysis was still there, so you can safely remove that. Here I forget to add any wells. Crucially, when you're setting up a rescan experiment, you don't need to define wells. You just need to have at least one well and one field of view selected. But the ones that you have selected are completely irrelevant because when you run it as a rescan experiment, it's going to run on the fields of view that your analysis sequence points out anyway. So it doesn't matter what regions you have selected when you're setting up your rescan experiment. Once you've got that saved and ready to go, you're then ready to actually run your PreciScan experiment. So you navigate to the Run Experiment tab, control mode, leave it in local. Remote has nothing to do with PreciScan. That's for when you want to use the robot arm that you're sitting next to. That's a whole different tutorial. Scan mode, PreciScan, obviously. That's the point of the tutorial. Select the PreciScan experiment from the database. Make sure it's the one that you've just set up. And make sure that underneath, once you select the right one, you'll see analysis 1 and the name of the analysis that you saved as the online job in your PreciScan experiment. Select the rescan experiment that you've also just set up and saved, hopefully with a memorable name. And just have a quick check of the summary panel to make sure that the plate type, the PreciScan lens, the rescan lens, the online jobs are all correct and relevant. Enter a plate name and click Start. So once we're all set up, we've got all of our settings saved, we'll move across into the Run Experiment tab. We will leave it in local. We will make sure we're in PreciScan mode. We will load our PreciScan experiment. And we will make sure that when we load it, you'll see in analysis 1, our PreciScan analysis sequence that we set up earlier has appeared. If that doesn't appear, go back to your setup page and make sure that you have saved your analysis as an online job within your PreciScan experiment. Then we add our rescan experiment. We make sure that the rescan lens and PreciScan lens are showing the correct lenses. We give the plate a name so that we remember what we were imaging. And then at this point, we are ready to press Start. You'll see at the top of the screen, the little turning wheel will appear next to Run Experiment. And once the analysis begins, you'll see the same thing next to the analysis sequence. Now here we are, skipped ahead to the end. You can see up on the left-hand side, there is a Load PreciScan button. So when you click that one, it will load our PreciScan experiment. We can now look over on the right-hand side. You'll see measurement, it says measurement 1A. A is for the PreciScan. And we can now click through our PreciScan images. But then if we click Load Rescan, you will see it will now have the same plate name, followed by measurement 1B. And within each well, you'll see our fields of view, and now slightly more sporadic because they are scattered wherever the rescan told us to go. And we have our higher magnification rescan completed. You can then run analysis on either your pre-scan or your rescan as you would run it on anything else by moving across into the evaluation tab and selecting either measurement 1A for your pre-scan experiment or measurement 1B for your images from your high magnification rescan. Now, the data management with PreciScan is a little bit tricky, a little bit more complicated than doing it for a normal experiment, just because you essentially have two of everything. You have a pre-scan and rescan experiment, you have an extra analysis sequence that goes in the middle, and then you obviously have pre-scan and rescan final measurements. So the easiest way to get your head around this is going to be if I just do it live. So you can see up at the top there, as we demonstrated on the last slide, you have measurement 1A and measurement 1B, and they're two different measurements. When you go to data management, same as usual, I find the best thing to do is to write an archive for the entire package of PreciScan materials all in one go and just keep it bundled together so that I have all of it saved on my hard drive and it can all be loaded back into the Harmony drive at once whenever I need it. But you will see measurement 1A and measurement 1B. You can also filter object types for PreciScan objects, which can make it easier to identify your PreciScan measurements and separate them from your normal measurements. But once you've selected all of the items that you want to save, you then move on to writing an archive like anything else. I don't do it here because I was actually on the Opera computer, so I didn't have anywhere to write it to. But this should all be familiar by now because everyone watching this tutorial is an advanced user of the Opera Phenix. And then to close up with a couple of tips, tricks, and common pitfalls. For the pre-scan, use the lowest magnification you can get away with whilst getting the minimum level of detail required for your analysis. This is because the lower your magnification, the bigger your field of view. Bigger your field of view, the faster your pre-scan. Also test your analysis sequence on multiple wells from different sections of the plate. What you don't want to do is set up your analysis sequence for one well, then it turns out that that well was a total outlier compared to the rest of your plate, and you now have an analysis sequence that doesn't work properly. You leave your experiment to run for 2 hours or whatever it takes, and then you come back and find that the analysis all went wonky, and your rescan is of a load of regions that are of no interest for you. You can also build, edit, and test your analysis using test images from the setup screen, so you don't have to run a full pre-scan experiment each time. You can do that by just pressing test images. Once your test images are loaded, click straight into the image analysis screen and it will load with those test images rather than requiring you to run a pre-scan. And then common things that people get wrong, or common things that I got wrong whilst I was trying to film this tutorial. Objective shift. Target cells are quite often not in the exact same spot that the computer expects them to be after switching from the pre-scan lens to the rescan if they're not perfectly calibrated together. So it's a good idea to add border fields around target objects. I mean, you saw in this tutorial, it was actually pretty spot on, but I was using a water lens and a water lens, so that helps. It's often a good idea with your rescan to add border fields around your field and also to add a 3D Z stack in case there's a bit of focal plane shift in between the two lenses. Air bubbles. If there's air bubbles in the pre-scan images, you get autofocus failures in the rescan. I mean, air bubbles are a problem for autofocus regardless, so just do your best to avoid air bubbles. If you're using a water lens, make sure that you flush the lenses before you begin the whole experiment to minimize the chance of there being air bubbles in there. And then disk space. Rescan file size can't be estimated in advance because it doesn't know how many images it's going to take. So make sure that you set a limit for number of fields in the determine well layout block when you're setting up your analysis sequence. And this will prevent you from taking too many images if, say, your analysis sequence goes a bit wrong, flags everything as interesting, and attempts to take 70 images per well. It just won't do it. Set your limit to 10, 15, whatever feels appropriate for the data that you need to capture. And then further reading, the user guide. It's all in there. Section 2.1, you get manual pre-scan, rescan. Section 2.11, you get automated pre-scan, rescan, which is PreciScan. And that application guide can be found really easily if you right-click anywhere in Harmony, just right-click on whatever you want help with and click the help button. And for any further information, further questions, please contact George Chanel, or Chen Lang. Thank you very much.